All right, so here is the study guide that I'm going to record for you. I am going to go through every single problem, and I'm going to make sure that you have the correct answers to study for the big test, that first big test. So I got to try and find my correct color here to match the color I started with over here. So here we go. The first one is find the multiplicative inverse of negative 2/3. Well, the multiplicative inverse, what we want to find is, if we're looking for the multiplicative inverse, we're looking for something that gets us equal to 1. The additive inverse, we try to get to 0, right? We just try and show the opposite. This multiplicative inverse wants to get us to positive 1. So what fraction can I multiply negative 2/3 by to get to positive 1? So the first thing I can do is I could eliminate every single one of these other ones except for the real answer, which is B, and that's what it shows on your paper, on what I posted and what's on your paper. We want a positive value out here, a positive 1. So I have a negative here. I have to multiply by another negative to get to 1. So already I have eliminated A, C, and D. But I want to show you that this works out if I use B, if I multiply by negative 3/2. All right, so I'm going to get rid of this positive. Well, I'll leave it here. All right, so negative 2/3, and I'm going to show the answer on the other side. Negative 2 times negative 3 is positive 6. And then, oh, geez, Louise, look what I did. I made a mistake already. That's supposed to be a 2. Sorry. There we go. First mistake of the day. There we go. There we go. Positive 6 over 6. Negative 2 times negative 3 is positive 6. 3 times 2 is 6. There we go. 6 over 6. Well, isn't that positive 1? There you go. There's your answer. Well, you could have just cheated and eliminated answers. We like eliminating answers. Start eliminating those answers. You've got multiple choice. Even if you didn't have multiple choice, you need to know that the multiplicative inverse equals 1. Let's move on to number 2. Change that color. This just says evaluate this expression here. If A is 5, there's our 5 that we put in for A, and Y is negative 3. So negative 3 is input here and input here. And now we just sort of do the math. And first thing we're going to do is multiply, do what's in the parentheses, right? We're not going to multiply because it says 5 plus negative 3. And 5 plus negative 3 is 2, right? And that's squared. Because, please excuse my dear Aunt Sally, says do parentheses first, and then 2 times negative 3. The next thing I'm going to do is evaluate my exponent, right, because I have an exponent here. So 2 squared, or 2 times 2. 2 times 2 is 4, and that's going to be added to 2 times negative 3. Now, you guys are really smart, and I know you probably could have evaluated this first, but I'm going to take this really slow and easy. 4 plus 2 times negative 3 is negative 6. Remember, a positive times a negative. My result, my product is negative. All right, so 4 plus negative 6. So I start over here on the number line at 4. I go back 6 spaces. I've crossed over the 0, and I end up at negative 2. And that's how you solve that ugly mug. Let's move back over here. The third one, Super simple, right? You just input and then take the absolute value. And remember, the absolute value always ends up positive because it's just a simple distance from 0. All right, so negative 2 times 8, and I'll put the absolute value symbol here, and I'll make it real big because I have lots of space, and I get negative 16, right? Well, how many spaces away from 0 is negative 16? Well, it's a full 16 spaces, and that's how I get there. Is it there? Of course it's there. There we go. All right, I'm going to move on to the next page. All right, now we have this formula, this weird formula thing. So here we go. I have, it says this formula, n times n plus 1, can be used to find the sum of the first natural numbers and find the sum of the first 20 natural numbers. Now this is the gift we've been given, right? We've been given the gift of the number 20. We want 20 natural numbers. So I put the 20 here for n and 20 here for n. That's what we substitute for our variable up here. All right? So let's do some math. The first thing I'm going to do is rewrite the 20 times 20 plus 1 is, oops, look at that. I was going to rewrite it again. That's what a goofball I am. There we go. 20 times 21 divided by 2 is equal to S. And almost last, this is 20 times 21. If you use a calculator, you'll get 420 divided by 2 equals S. And then you take half of 420 and you get 210. All right, I know I put the S on the other side. It doesn't mean that there's anything different. That's just the way it is. All right, so I'm going to move over here, change my color real fast. I think I used this color. Oh, gosh, I hope I did. Anyway, here we go. This is a pretty easy one. You just need to know the definition of all these types of numbers. So rational numbers are numbers that can be written as a fraction, right? And real numbers are everything. So far, this is a rational number and a real number. Is it a natural number? What are natural numbers? Natural numbers are the whole counting numbers. Naturals are the whole numbers starting with 1. They're all positive whole numbers starting with 1. Those are the counting numbers. That's what we were talking about in the previous problem. And this is not a whole number, so this goes away, right? Is it an integer? Well, integers are positive and negative whole numbers, so that doesn't work either, right? So it is rational and it is real. It does exist, right? So really and truly, to make this perfectly set up for us with all the sets that it belongs to rationals and reals. So that would be letter C. Okay, and then I'm going to move down. I don't remember what color I used for this. I'm going to guess. Nope, it's got to be this one. All right, so I'm going to start doing this math here, and hopefully I have the right color to do it. This is just simplification. That's what it says, simplify. All we're going to do is distribute, right? We're going to multiply this by this, and that is the wrong color, but you guys will survive it, right? And multiply that by that. And what we come up with, it's probably this guy. What we come up with will probably be something that can be simplified. We have, x terms, and we have whole terms, okay? So, or constants, as we like to call them. So 2 times x would be 2x. 2 times positive 3 would be positive 6. And then over here, we're going to put that addition symbol in between. And then 5 times 2x would be, 5 times 2 is 10x. And then 5 times minus 1 would be minus 5. Now, once we get here, we can combine our like terms. So we have a like term with our x terms, and we have like terms with our constants or our whole numbers, right? It's positive 6 and negative 5. Don't forget that negative there. Subtraction and negative are the same thing. So we put our 2x and our 10x together, and we get to 12x. And then positive 6 and negative 5 just net me a positive 1. Now, when you got to 12x, you could have eliminated this bad boy right away because it doesn't exist. And then the thing that the problem was trying to get you to think about was this back end. Don't forget the negative. And so that was letter F. Good. And you saw that it said letter F on the paper. Good. Let's move on. Let's go to the next one. The next one says select, select, I got to get there. I got to go there. There we go. Select the algebraic expression that represents the verbal expression, the product of 9 and a number. So product, of course, means multiplication. Product means multiplication. This is division. This is subtraction. This is addition. If you know that product means multiply, then you would have eliminated all these others, and you would have seen that 9n is the way to go. Now, we move on. Here we go. 1/2 y equals 8. Well, half of y equals 8, so we need to undo this multiplication by a fraction. We need to divide by a fraction or multiply by the reciprocal of that fraction. I want to turn this into 1y. How do I turn it into 1y if I have half? Well, guys, I'm going to multiply that half by 2. Why? Because if you have 2 halves, you have a whole. Okay? So if I multiply this by 2, the multiplicative property of equality says I have to multiply both sides by 2, or else my scale is uneven, the bar is uneven, all those things that we've talked about before. So I'm going to go back here. Once I multiply 2 times a half is 1. So now I have that 1y sitting there, and of course 2 times 8 is 16. Is that one of the answers up here? Of course it is. It's F. There we go. Moving on. I'm going to try not to take too long doing this. This next one is just a simple multi-step equation, and the first thing I have to do is distribute this 4. Distribute the 4 here, distribute the 4 here. All right, so I'm going to do that. I'm going to do 4 times 2x, which is 8. Keep the x, minus 4 times 9, which is 36. Oh, numbers are getting big. Equals 3x plus 4. We haven't done anything with this side at all. Now, I'm gonna move my x's to one side. I like to keep my x's positive, so I'm going to undo the 3x over here. That goes away. Minus 3x over here. Now I have 5x minus 36 equals 4. Okay? Well, I'm getting real close now. Now I have a nice two-step equation here. I'm going to add 36 because I want to isolate the variable. That's my goal, right? Oh, I don't need that equal sign. Let me get rid of that for a second. Plus 36. This goes away. I'm left with 5x on this side equals 4 plus 36 is 40. Oh, look at this. It's going to come out to be a nice whole number. So I can get rid of those two fractions right away, right? I know where I'm going to be headed. I know this fits in nice and evenly. Is it negative 32? No, it's going to be 8. So you could finish there, but let me go ahead and finish by, dividing both sides by 5. Divide by 5. And then go back to my regular color. X is equal to 8. And of course, they showed you that D was the answer. All right, going to move on. Here we go. We have it all set up. Hopefully I have it all set up. I don't know what color that is. I think it's this color here. This is another simple equation. You're going to have to you could distribute first, but the trick here is not the distribution. You don't really have to distribute here. You could divide both sides by 4, right? Because this being multiplication, if you undo the 4 by dividing, that goes away and it's x plus 3. If you divide this side by 4, you do get a whole number. So if that side is divisible by what's outside here, let's do it. So I'm going to do that. I am going to divide this whole thing by 4 and divide this whole thing by 4. Now, you guys, you don't necessarily like it, but it is perfectly valid to say x plus 3 equals 20. All right, and now we just subtract 3 from both sides. Ah, I made a mistake. Did you see it? It's not 20, dummy. It's 20 divided by 4, which is 5. There we go. Fixed it. All right, so now subtract 3. Whee! See how much fun this can be? All right, 5 minus 3 is 2, and so x equals 2. Now, because it's absolute value, we have to solve for the negative version of this equation. I think it's still this. I'm going to do the same thing, though. I'm going to do that same dividing by 4 on both sides. Why? Because it's going to make my life easier. So I end up with x plus 3 equals negative 5. Now we need the negative version. What can we put inside this parentheses, which isn't really parentheses, but it's the same idea. It's a quantity inside the absolute value symbol, so we use parentheses when we solve. Now we're going to solve this by subtracting 3. That goes away. Minus 3. Negative 5 and negative 3 are negative 8. All right, and let's see if we have the solution set of 2 and negative 8. Hey, look at that. 2 and negative 8. Right? I don't know why I jumped to number 11 first without doing number 10, but I'm going to jump back to number 10. I apologize for making that mistake. The big thing you needed to realize when you do these absolute value equations is to solve for both the positive and negative values of what's inside the absolute value. Okay, and so I am just going to solve normally here by adding 5 to both sides. I think this was the easier of the two absolute value equations. X equals 4 plus 5 is 9. And, you know there are going to be two answers, so it can't be just F, and it can't be the empty set because this exists. And then we're just going to guess that it's H, or we can just do the math over here. We're going to add 5 and add 5. Uh-oh. I wrote it wrong. Yay! This is supposed to be a 4. It says 4 up there. I don't know why. Let's make this a negative 4. And a 5. Jeez Louise, what a day, right guys? Sokol's made 4 mistakes already. It's really 3, but that's cool. There it is. Wow. I wrote it out wrong. I even tried to prep all this stuff for you guys because it's going to be a long video. Here's the next set. Let me grab the right color. This is a simple explanation. There's nothing cool about this. It's which equation could be used to solve the following problem. The sum of 4 times a number and 7 is 31. Okay, so here's our biggest problem. 4 times a number and 7. So it's not the sum of 4 times the quantity of 4 times the quantity of a number in 7 is 4 times the sum of 4 times the number in 7. So we're looking for 4 times the number plus 7. And this is the only place where we have 4 times the number in 7. If it said something like the quantity of, or 4 times the sum of a number in 7, if this wording were moved around, right? The product of 4 times the sum of a number in 7, we would use this guy up here. So we knew that these guys, this here wasn't going to work. This is 4 times, this doesn't work. Has to be where the 31 comes in. So you were just choosing between F and J, and it's actually J. So read carefully. That's all I can say there. I've explained it. I don't want to beat that dead horse. I'm going to move on. So I'm going to go to 13 since I decided to do this in the correct order. Amar is 5 years older than his sister. The sum of their ages is 39. Find Amar's age. So we're going to make Amar A. We're going to make his sister A minus 5 because he's 5 years older than she is. Okay? Now we have that in order, and together we add A and A minus 5. That equals 39. So all we have to do is simplify, right? I can add A plus A, and I have 2 A's. Minus 5 equals 39. I'm going to add 5 to both sides. Right? That's the addition property of equality. 39 plus 5 is, so 2A equals 44. If I'm not mistaken, and A equals 22. Oh, sorry, let me go back. A equals 22. You already know that, but I'm going to show how to get there just because I should. Divide both sides by 2. All right. And now I'll write it correctly. A equals 22. 14. Here we go. Are we scared? Don't be scared. This is just a simple inequality. The rule, you see this negative in front of the 8W. I think the big trick of this one is make sure you flip the inequality symbol when we get there, right? We're going to get to a point where we're going to divide across an inequality by a negative. They want you to remember that idea. So we're going to first get rid of the 4. We're going to undo the plus 4 by subtracting 4. And so we get 8. And so we get negative 8W. Sorry I didn't use the exact same color, but I don't want to mess around. Now, I'm going to use a bunch of different colors here. I'm going to divide by 8, negative 8, right? Because I want a positive variable, and that gives me W down here. I'm going to divide by negative 8, and that gives me negative 1 down here, right? And you already knew this part of the answer. What you may or may not have remembered was the trick that says if you divide across an inequality by a negative, the inequality symbol has to turn around and face the other way. So what did they do? They tried to trick you by putting that here, that if you left it alone, you'd come up with H. But that's not the case. F is our answer. W is less than or equal to negative 1. If you want to plug, 0 in, because that's less than negative 1, you'll see that what you get out is a valid solution for this answer. Sorry, less than negative 1. Less than negative 1. So if we go with negative 2, that negative 2 is less than negative 1, right? So negative 2 in here, would be positive 16 plus 4 is 20, and that's greater than 12. Anyway, here we go. That is that. We are moving along. Oh, only 2 of them on this page. I guess this requires a lot of space. So let's go grab that color here. And let's just go and do this. And what's neat about this is we're just solving these inequalities, right? Don't forget there's a negative x here. We'll get to that shortly. This is simple, 2 steps. Add 1, add 1. Now we have this gone, and 6. Keep our inequality symbol, 2x. Divide by 2, divide by 2, and x is less than or equal to 3. Well, we have that there, and we have that there, so we're not sure whether it's A or B, but these guys are gone. Right, so let's go ahead and move on to the second half of this show. I need to get rid of this positive 7. I'm going to subtract 7 from this side, subtract 7 from this side, and this goes away. 1 minus 7, so negative x or minus x is less than negative 6. Oh, we have a negative x. We're going to multiply or divide by negative 1. Divide by negative 1. And now this inequality symbol turns around, right? So it's x is greater than 6. Okay, so what do we have? Is x less than 6? No, x is greater than 6. So this guy goes away, and we are left with B. It does indeed start and end as an OR statement. So if we graphed it, it would be looking like closed circle, open circle, something like that. You know, the right values there. All right, let's move on. This one is cool. This is how I like to do it. I like to do everything at once, okay? This is 3 distinct quantities, right? This is like a balance with 3 separate pieces, right? So I'm going to undo this 1, this plus 1 with minus 1, but I'm going to do it here. And to keep the balance, I'm also going to do it over here. So negative 3 minus 1 is negative 4. Going to keep the inequality symbol is 2y is less than or equal to 9 plus negative 1, or 9 minus 1 is 8. Right? And then I'm going to do the same thing I just did. I am going to divide all 3 pieces by 2. Why? Because I want to isolate one single variable as opposed to having 2 of them. All right, so divide everything by 2. Go back to my original color. Negative 4 divided by 2 is negative 2. Is less than or equal to. Why? Because 2 divided by 2 is 1. Less than or equal to 8 divided by 2 is 4. Is that one of our answers? Yepper-doodle. It's J. Wow, I'm sorry about the yepper-doodle, dudes. All right. We're getting very, very close. 17, awesome. This is a super long video and really, really annoying. All right, the big trick here is it's an absolute value inequality. Therefore, we have to solve for the positive value, but when we solve for the negative value, we have to flip the inequality symbol. So I want to make sure that you flipped the inequality symbol when you solve for the opposite value. So we solve them normally. M plus 8 minus 8 minus 8, right? So that goes away. This nets me negative 5. M is greater than negative 5. So far, this is all I've got. I can just stop right here, select C, but I want to make sure I did it right. So let's go ahead and look. Let's subtract 8 again. That goes away, minus 8. I've already flipped my inequality symbol. I'm going to bring that down when I put my negative 11 down here. Inequality symbol is flipped, m. Okay, this happens to be an OR statement, and there it is. M is less than negative 11, and m is greater than negative 5. It's got to be this bad boy right here. Okay, we'll move on to this ugly mug over here. I think it's this color. You'll see I've already flipped the inequality symbol for the opposite value on the right. Sound good? Great. This is just add 5, add 5, and 9 plus 5 is what, 14? Keep that inequality symbol, 2x. Well, what am I going to do? Duh. I'm going to divide by 2, divide by 2. 2 divided by 2 is 1, so let me get back to my color, is x is less than or equal to 7, right? And then you see, you look around, you look around, you look around. The only one that shows that x is equal to is less than or equal to 7 is right there. But I want to check my work just to make sure I didn't make some sloppy mistake, and I'm going to go ahead and do this one too. So I'm going to add 5 just like I did before. That goes away. Plus 5. All right. Now I got negative 4. I had already flipped my inequality symbol, so 2x is greater than or equal to negative 4. Divide by 2 on both sides. X is greater than or equal to negative 2. So this actually looks like an AND statement, right? And remember what we said. If you're looking, and I'm going to just use some space over here, if you're looking at an absolute value inequality, just if you can remember that this and this give me an OR statement, and this give me an AND statement, that might be helpful when you're going through this stuff. Okay, and let's get to the last of the real problems. I will do the one bonus problem that's on there, but I don't want you to worry too much about this. 19, I just wrote eliminate. Eliminate answers, you know. Yeah, you could do this work. Go ahead and let's use a different color. Sorry about that. You can't see that color, so I'm going to just use black. Subtract 3, right? Subtract 3. So we end up with 6 is greater than 2x, and so x or 3 is greater than x. Okay, so we have 3 is greater than x because we divided by 2 over here. Here's our problem. We want to read it x is less than, because x is less than, because the point is pointing at the x, the mouth, you know, the big part is pointing at the 3. So 3 is greater than x, or x is less than 3. Here we go. Now, you can eliminate, right? Eliminate because this is a closed circle. That's garbage. This does not have an equal sign underneath it, so these two are garbage. Throw out b and d. Now we have x is less than 3. They put the x on this side just to trick you. This is your trick. Don't fall into that trap. X is less than 3. If you read it backward, x is less than 3, you're good to go. Or if you want to rewrite it, you know, rewrite that sucker. You say that 3 is greater than x. Well, rewrite it, making sure that the inequality symbol is still pointing at the x, you know, the point of it, and the big mouth of it is open to the 3. Now, these two things are exactly the same, just written in the opposite order. Now we see x is less than 3. We're used to seeing that. We know that that's letter A. Last but certainly not least on this sheet is the idea of the parking. And we hate reading these word problems. We don't know how to do it. We get very, very upset. Here we go. This says you get $2 the first hour. And so I'm going to write plus 2. The problem is I've already used up 1 hour, okay? And so I need to be careful that when I do my $1 an hour, and I'm not even going to put a 1 here. I guess I'll put a phantom 1 here. I'll put an implied 1. There's a 1 in front of this x, right? $1. And this is $2, and this is $7.50, right? $7.50. So there's an implied $1 here, minus 1 hour. 1 hour, right? Because per hour, and we take off the 1 hour because we have that $2 that you're automatically charged when you walk in. First of all, I would love to park in a parking garage that only charged $1 an hour after just charging you $2 for the first hour, because boy, when I go to New York, I pay an arm and a leg to park in a parking garage. Either that or they probably just destroy your car and you never want to park there again. So let's move to this idea. I want to change my color. There we go. Let's try this color. It's more fun. All right. So I just need to solve this, right? So this is basically x minus 1 plus 2 is less than or equal to 7.5, right? So I put these two things together. So x plus 1 is less than or equal to 7.5, because I put my minus 1 and my plus 2 together. Now I'm going to subtract 1 from both sides. Minus 1. And x has to be less than or equal to 6.5, right? Well, they don't charge by the half hour, they charge by the hour. So the truth of the matter is we can sort of negate this guy because it doesn't get to that full 7 hours, and we end up with 6. Good? Here's the bonus question. And the reason it's a bonus question is because it says, hey, solve this. I'm going to go ahead and use the small brush. That's what I used in the beginning. It says, go ahead and solve this. And I haven't given you any multiple choice answers. That's what it says. Okay, here's the big deal about this particular bonus question. It's that guy right there, that negative that's going to get in your way. They think you're too stupid to realize that you're going to be flipping these inequality symbols. But you're smart, and you're not going to forget that, okay? But what do we have to do first? We have to get that variable by itself. We have to isolate that variable. So we're going to subtract 7. If I do it there, I have to do it here, and I have to do it here. Okay? So 11 minus 7 is 4. Less than or equal to negative x. Don't drop the subtraction. It doesn't go away. It's still minus x or negative x, negative 12. And here's how this really works. You really think that x is going to be less than negative 12 and greater? No way. No way. So we're going to divide everything by negative 1. Divide by negative 1. Divide by negative 1. That gets rid of this negative. Negative divided by a negative gives me a positive, right? 4 divided by negative 1 is negative 4. Negative 12 divided by negative 1 is positive 12. Now, what is the rule? I have divided by a negative across inequalities. So this inequality symbol changes around. Perfect. All right. So this actually, believe it or not, is a goofy looking statement. This says x is greater than 12 and x is less than or equal to negative 4. This turns out to be an or statement. Believe it or not, it turns out to be an or statement because of this negative. So this is x is less than or equal to negative 4 and x is greater than or equal to 12. Okay? And this becomes an or statement because there's no space in the middle. All that space between negative 4 and 12, empty. Right? Because x can't equal 0. Because 0 is not less than negative 4. 0 is not greater than 12. So when we graph this on the number line, we got to make sure that this works out. Right? Let's say I put in a 1 here. Well, 7 minus 1 is 6. Is that less than 5? No. 7 minus 1, that's 6. Is that greater than 11? No. So we know that we have this space out here. And this is negative 4. And I'll make this 12. And we have everything pointing away. Greater than or equal to... Oh! I made a mistake over there, but this should be an open circle. I added this here by mistake, and this here by mistake, and this here by mistake, because I got excited over there. Open circle to the right, closed circle to the left. Good? That's it. Good luck. If you have any questions, please let me know. Thanks so much, guys. Sorry it was so long.